Exercise 4C, question 7. So we're on the final question of the exercise, quite a big one, worth about 14 marks according to the guideline marks. Quite a typical question. You may not get one this detailed in an exam as it takes up quite a lot of marks, but it's fairly typical in structure. So we've been given a large proper fraction. It's a quadratic over a cubic looking at it, and we've been asked to split it into the form. So it's given us the form, so they're being relatively nice there. In an exam they could just jump to the series expansion and it would be up to you to realise that you needed to do the partial fractions first. So because they've given us the form, I'm going to go straight to multiplying through by the denominator of the fraction. So I've got 2x squared plus 5x plus 11 on the left hand side if I multiply through by the denominator, and on the right what's going to be left next to a? Well, it's got a 2x minus 1 underneath it, so it'll cancel out one of the 2x minus 1s, but the other one will be left, as will the x plus 1. If I look at b, that is going to lose both of the 2x minus 1s because it's got a squared on the bottom and be left with just the x plus 1, and then c will be left with both of the 2x minus 1 brackets, so squared. Okay, so now I've done that, I can go for chucking values in. X equals minus 1 will give me 8 on the left hand side. Everything with an x plus 1 will disappear, so I'll be left with c, and that will be 9c. So c is 8 over 9. So they're being less kind to us this time, giving us fractions again. X equals a half, we'll get rid of 2x minus 1. I will get 14 on the left-hand side. Again, just pop it in your calculator. And 3 over 2 blocks of b on the right-hand side. So b is 28 over 3. Okay, now, obviously, whatever I stuck in got rid of a. Okay, so you could then substitute in, I should say, x equals 0, x equals 1, anything else, and then look at the left and the right hand side. But this is another nice one because the only place that I can get, actually there's a couple of places I can get x squared, so I'm not going to do my comparing coefficients method. I'm going to change my mind mid-flow. So I'm actually just going to stick x as 0 in. Had that only had one place to find x squared, I could have just compared coefficients, but of course I can get it from the a part and from the c part with that squared on. So if I do 0, I'm picking 0 because it's easy, I will get minus a plus b plus c. Now I know what b and c are, so if I substitute those in, I will get a equals minus 7 over 9. Okay, so now I've found my A, B, and C as required. I'm going to go for the expansion. Now, rather than write this in fractional form, I'm going to write it in index form. Okay, so I've got minus 7 over 9, 2x minus 1 to the minus 1. Okay, bringing up the denominator, plus 28 over 3, 2x minus 1 to the minus 2, plus 8 over 9 x plus 1 to the minus 1. Okay, so I'm going to have to do that expansion, and for lack of a different colour, that expansion. Okay, so we're going to take these one at a time, and then we will slot them back into that statement to do all the algebra to finish. So let's start with 2x minus 1 to the minus 1. Remember what we said? We much prefer that written that way around. It's just psychologically, I don't know what we're used to, I think, which makes it easier. Now, I don't want a 1, so I'm going to have to bring out that minus. Now, that minus, I'm going to call it minus 1 and do this properly, will be to the minus 1. 1 minus 2x to the minus 1. Now, minus 1 to the minus 1 is just a negative. Okay, so I will have negative 1. Now, if I do minus 2x times minus 1, that's plus 2x. Rather than write 2 of them, plus, but I'll be good on this one, minus n minus 1 over 2 factorial minus 2x to the power 2. I only need to go up to a quadratic, which is good. So I'm just going to leave that there. Okay, so I know if I simplify that up, I will have -1 minus 2x minus 4x squared. Okay, did this question mention validity? No, so that's okay. Right, so that's that one done. Let's go on to the blue one. So I've got 2x minus 1 to the minus 2. So again, swap it round. Bring that -1 out, put it to the -2. Now, -1 to the -2, you can either use your calculator or think of your laws of indices, is just 1 over -1 squared, so 1 over 1, 1. So actually, I'm just going to need to expand the 1 bracket. So -2x times -2 is +4x. And then actually, if you realise it, we were actually doing exactly what we were doing before in terms of the expansion, but this time I'm going to have to do -2 for n and -3 over 2 factorial minus 2x. So nearly the same, but actually slightly different. Okay, so if I look at that one, that cancels. Oh, lost the squared. I'm going to have 1 plus 4x plus 12x squared. So that's that one done. Right, last but by no means least was 1 plus x to the -1. Now I've swapped that one over because it was x plus 1, 1 plus x, easy swap. Now actually we've done this one before many times, so it's 1 minus x plus x squared. Do it in full if you're not sure. It's just by the time this point in the exercise you have done that one a few times, so you may recognise it. So now I've got all 3 pieces. I just have to put them all together. Now I do like to write the expansion ... or something like that, just because you're just jumping into a new line of working. So -7 over 9, lots of -1, minus 2x minus 4x squared, plus 28 over 3. The second expansion was 1 plus 2x plus what was it, plus 4x squared. Oh no, wait a minute, that's a 12. Let me just double check my notes. All right, scratch that one. But you can tell, actually, the first time I did this, I did make an error, so my notes needed fixing. It's so easy just to lose a power, a bracket, a negative 4x plus 12x squared. Okay, and then I have the last bracket. I'm just going to have to squeeze that in here. 8 over 9, 1 minus x plus x squared. Okay, so if we have a quick, at this point, because there was a lot of writing, let's have a check. So I've got -1, -2, and -4 for the first expansion. -1, -2, -4. 1, 4, 12. Check, and 1 minus 1, 1. So that matches. I did them in the order that they appeared, so that all slotted in nicely. Now it looks a real mess, this one, but actually when you stick it in your calculator, you get 11 plus 38x. Oh, it's got a bit high. Plus 116, so 116x squared. So actually it all works out reasonably nicely in the end. Now, part C says to work out the error when you are putting 0.05 in. So first things first, if I put 0.05 into the function that I was given in the question, okay, that was 2 lots of 0.05. And again, it's worth showing this line of working to show where you get your values from. All over 2 lots of 0.05 squared minus 1 all squared, 0.05 plus 1 close brackets. And that will give you 13.2333912. Okay, so again, I've shown the marker, if this was an exam, where I got that value. I got it from putting it into that. Now, if I use my expansion, that is 11 plus 38, 0.05 plus 116, 0.05 squared, which is 13.19. Okay, so you can already see it's looking pretty good. So, percentage error. Okay, that is supposed to be a percentage sign, slightly avant-garde. Right, percentage error is your predicted minus your actual. So actually, because I want percentage error, not percentage difference, I just want the error. So I'm actually going to do the larger one, take the smaller one in this case. So 2,333,9,2,1,2 minus the 13.19. Because I just want the error, I'm going to do it so that it gives me the error, as in the size of the error, not the plus or minus direction. Over the actual, remember it's always divided by actual, times it by 100 to get a percentage, and you get 0.33% error, which is really good, especially considering it's only up to the squared term, helped by the fact you're putting in a very small number, a number very close to 0. Okay, so that is that exercise finished.